Hi and welcome to another Build With Me project. This one's going to be a little bit shorter than the last couple, as this is a very simple kit. It's an electronic dice or die. As you can see, I've got it powered here just via USB. It is designed to be powered by two little lithium cells, but actually this can draw quite a bit of current. This is it just in its sort of resting state, and then to get it shaking you can turn it upside down. It's got a little vibration motor. As you can see, it's taking near 100 milliamp whenever it's doing that, and even at resting it's still taking sort of 15 or so milliamps. So your coin cells are not going to last very long with this. Hence, I just used a little USB lead and soldered that in instead. So let's see what comes in the kit contents. So it comes in a pack of 3 of these kits. So I've got the one that I've already built up, and I've got 2 more. It's a very simple kit. We have a little piece of Perspex which forms the back of our circuit board, our kit. The circuit board, which we'll take a closer look at in a minute. We have our lithium coin cell holder. In fact, it takes 2 cells. And we've got some LEDs. They give you a spare one as well, so that's very nice. 1 solitary resistor, our little motor that vibrates, little STC microcontroller. What I originally thought was a capacitor, but actually it is a switch. It's it senses the direction that it is. So you may be able to hear that, but there's a little weight inside there. So it's just like a little gravity switch and a little transistor. Little switch, and then some nuts and bolts. So let's just move that off to one side, and then we can have a closer look at our printed circuit board. I'll just zoom down a bit. So this is the side that obviously the LEDs go onto. We have got the little silk screen indicating the flat for where the anode and cathode are to be, and also of course the square pad as well, usually denoting for the longer of the 2 leads. And then on the other side we have very little in the way of a silk screen, obviously for our resistor and our transistor. Big disc here, this is for our coin cell holder. This disc here is for the motor to stick onto, and then we put our chip here, and at least we've got the silk screen showing pin 1, of course being the square pin, or square pad I should say. But something you may notice about these compared to my giant fingers is that these pads are very small. Now this is supposed to be a kit for a beginner. Let's just see there. So sub 1 millimeter in diameter, these pads. So these are not the easiest to solder. As you can see on here, very little of a pad outside the hole. Turn it over and it's exactly the same. So it's not so easy to solder for a very beginner, I would say. Even somebody more experienced may have difficulty with this. You need a fairly fine tip on your soldering iron, and then you just need to be careful. Now on the page, the shop where I bought this from, the link will be in the description below. On the item description, it does have a link for instructions. But when you click on it, it asks you to log in or to seek permission to be able to view the file. So not very helpful there. But it's so simple. We should be able to figure this out from the pictures on the web page, or that's how I built up this one, and we can certainly refer back to that if we need to. So let's get on and build this little dice kit. So some additional things that you're going to need that don't come in this kit. First of all, a soldering iron and solder. I'm using a good old 6040 leaded solder. Also, a pair of side cutters will be very handy for clipping off the leads as we've put them in. You're also going to need some batteries for this, or a USB lead to hack and put in its place. So let's get on. Let's start with the smallest and shortest component, the resistor. I have no clue what value that is. I haven't even tested it. There's no point because there's only one of them. So we'll just bend that up and see what I mean about these pads being very small. It's very hard to actually get the soldering iron onto them. You end up relying on the solder to heat the pad up. And then we can clip off those. The first component in. Now, I'm trying to figure out what's the next smallest component. And I think it's actually the little microcontroller. Yeah, got it upside down there. All the electrons will fall out, as somebody would say. There's the model number for those who want to know exactly what it is. No socket provided, so it just solders straight in. Of course, you want to be careful with this, especially if you're new to soldering, not to leave the soldering iron on the pin for too long and create too much heat getting through into that chip. And it's good just to wait a few seconds and also stagger where you're soldering, just to allow the heat to dissipate. It's very easy to not solder these up because of the pathetically small pad size. See, there it is again. I'm getting heat into the pin of the chip, but I'm not getting the heat into the circuit board because the pads, the solder pads, are just so small. Once we're finished, we'll go over these or look over these zoomed in even further, just to make sure that we've got all these joints made okay. But back onto the top layer again. And let's go for our transistor. Now, as you can see on the silk screen, we've got this little shape like a D. And if I hold this transistor like this, you can see it is a similar shape, or at least it has a flat that corresponds to this. Now, we could solder it all the way down like that, but with transistors, they are also very temperature sensitive. And so what I like to do is put it all the way through, splay the leads, and then just pull it back just a little bit. And then we can use our cutters here to stop the whole thing collapsing in whenever you try to solder it. So we just solder one lead in, and then we can take a look to see if we need to straighten or adjust it. That looks just about okay. Now we shall try and do the difficult one. This is the center one. This is the easy one to bridge. Then let that cool, and then we'll go for this last one. So you can see there we managed to get away without making a complete mess of that. It's always good to hold on to those leads whenever you clip them off, because otherwise they go absolutely anywhere. And you'll only find them later on whenever you're walking barefoot through the room. Let's move on. This is probably the next tallest or short-ish component. Helpfully on the PCB, they've got a plus and a minus. So your guess is as good as mine as to which they refer to, because we have a red, which you'd think is plus, and a yellow, which we're going to assume is the minus. But it's not exactly following some sort of convention. These wires coming out of here are extremely fine, and they're solid cord as well. I'm trying to strip the insulation on these wires. It's really tricky, so I don't bother. What I do is I get them like this, and bring your soldering iron up, put a good blob of solder on the end, and then just tin the ends, and you'll find the insulation will shrink back, really revealing enough of the conductor to be able to be soldered. And then if we tin the pads, tweezers are helpful. You don't have to, but they are definitely helpful. See if it falls off. Nope, stays on. Job's a good one. There we go. Now this has got a self-adhesive back on it. Those of you with normal sized fingers might be able to just peel it off. I've got to use tweezers. There we go, we even got it nearly inside the circle. Just a little bit of a firm press on it there. Excellent. I think the next tallest item will be our little switch. This is a very cheap and nasty switch. If you breathe or touch it the wrong way, you'll notice the LEDs will dim. So we'll do the same again. We'll just solder one pin in and then check to make sure it's nice and flat on the circuit board. And of course on this you don't really have to be as careful about getting too much heat put into it, as it doesn't mind getting too hot. Just clip those leads down, keep things nice and neat. Now we move on to, well actually this is not the next shortest component. The next shortest component is our little battery holder. Notice it has got the little square cutout for the positive, which is this top pin. It also has a plus, if you can sort of make out there, sort of stamped into it. But notice, if we solder this in, we're going to have great difficulty soldering that LED in. So we're just going to hold off on these two components, and we'll put in the LEDs next. Now you can do these one at a time if you want. but I find it's just as easy just to do them all at once. You notice that there is a flat. If I turn it this way, you can see the flat is on this side. If it can focus on it, there you go. So the flat is on that side. The flat is on the side with the shorter of the two leads. The long lead, just square, which will go into the square solder pad. That is the normal convention. Of course, it's always wise to check, because some of these kits are very, very cheap for a reason, in that they don't always follow convention, or they may use parts which are perhaps not standard. But helpfully they've put all of these LEDs in the same orientation. So that means that you'll either get all of them right, or you'll get every single one wrong. But maybe that's why you get 3 of these kits. There we go. So you can see the flat on the silk screen, and you can also see that there's the flat on the actual LED itself. Now, to be able to turn this over to solder it, what I do is I just slide in this little acrylic piece and turn it over, holding those 2 bits together. Then we'll do, as we've done with others, we will just solder up 1 pin on each LED. Then we can check it later and make any adjustments quite easily. Again, you have to be careful with this not to overheat these LEDs if you can help it. And when you turn the thing around, it's easier if you turn the bottom piece as well. Yep, that's them all in. You can then turn them over, have a little look to see have they stayed sat close to the board. Almost all have. This top one seems to be just a little bit out, so you just reflow that joint and press down with your finger. The same with this one. Then we can just go through and solder up the other pins. Now, making sure, of course, that these 2 joints here are soldered in okay. They look okay. Let's just have a quick zoom in and tilt them, because whenever we put our little battery holder on it, we're not going to be able to get at those joints, because even from the top they're not accessible for us anymore. So just zoom you back out again. And now we can do this. So same thing again, we shall just solder 1 pin or 1 pad and just see if that, and make sure that that is in the right place. We can see that we've got our little square sticking out piece lined up on with the silk screen, so we know it's the right polarity. Excellent. So we only have 1 more physical component or electrical component to go on the board, and it's this little switch. You can feel a slight rattle whenever you shake it, so it's like a vibration or movement sensor of some description. Just try and support the circuit board while we solder 1 pin in place. far too much solder on that, which might be masking whether that's actually made it a good joint or not. It's just so difficult on these. And do you see, let me zoom that in on this. I can highlight a little issue. Do you see the way the solder is not really stuck to this side of the pin? This pin may have had a bit of a coating on it, although the other side seems to have soldered up okay. But you can see a similar effect happening here. So I'm just going to reflow this. I'm going to clean my soldering iron, and I might actually just pop a little bit of flux on it. Generally you don't really need to whenever you're using through-hole soldering with that, but I'm just going to do it on this one just to help clean whatever is stopping the solder there from properly sticking. Also, by just rubbing the soldering iron up and down, sometimes can remove whatever impurity was preventing the solder from sticking. Seems to be solving it. And then just have, while we're zoomed in, just have a little look at the rest of these joints just to make sure we haven't either missed one or made a dodgy joint. And if there's one that looks ever so slightly not quite right, to my eye anyway, it's this one here. So I shall just flow a bit of fresh solder onto that. And then looking at things from the top, seems to be looking all okay. So now I just need to go and find a couple of batteries that we can put into this and test it. So, not having the right size battery in stock, I'm going to do the right thing and just fit these ones, which are slightly the wrong size or thickness, but it should work okay. These are CR2025, that's 20 millimeters in diameter, as you can see with this steel rule, 20 millimeters in diameter. By 2.5 millimeters thick. So the ones that are recommended for this are 2032, so 20 millimeters wide in diameter and 3.2 millimeters thick. But you can see the spring of that arm should be able to incorporate these wrong size batteries. First of all, we're going to turn it off so it doesn't try and spring into life. And then we shall endeavour to get these in. So it takes two batteries. Now we turn it on. It is buzzing away. And while you can see the LED flickering there, to my eyes that is not flickering. I don't discern a flicker on that. So it's just an artifact of the camera picking up. And it has a little hum or buzz whenever that, or it did have, it's now stopped. So you can shake it. Shaking it doesn't seem to produce a very random result, whereas if you actually turn it upside down, it does do a bit more of a random result. Anyway, let's turn that off. We know it works. And then we can put the hardware side of things together to make this complete. This is where having some sort of magic instrument that can take off this paper is really helpful, because I don't know whether it's the process of the laser cutting of this. It seems to fuse the edges of this paper very much onto this acrylic. Now the pictures and how I built this first one show putting the screws in from the side of the LEDs and then putting the nuts on to hold them in place. It's interesting. This powered by USB, this one, has a much stronger vibration motor than the ones powered just by these batteries. Right. And what holds this acrylic plate in, again, terrible practice, but they just crank it down, screw it down, and it's the little switch that holds it in position. Whereas if they'd just supplied you with 4 more nuts, you would be able to space it off and bolt it down to those nuts. You could put nuts underneath this acrylic. So yet another corner cut. But then these were a very cheap little kit. I believe they come in different colours as well. So this is where I try not to put too much strain on that switch. And that looks about even. And that is it finished. So we can turn it on. It runs fine on just 5 volts, even though this one's got 6 volts, and it says it's rated for 6 volts, but it'll run fine on 5. And what might be an idea is actually, because you get 3 of these in a kit, is to put either 2 or 3, or however many you need for whatever game you're wanting to play, put them together and, I don't know, stick them with either sticky tape or a cardboard, or make up some sort of 3D printed jig to hold them all together, wire them all up to a USB power supply, and then you can just have them sort of, you flip them all at once, and what do you know, you might come up doubles like that. Anyway, that's just a very simple project, pretty ideal for a beginner. Thank you so much for watching, and we'll see you on the next project.